Hi bowling fans, Hank Boomershine here. A little more tech talk coming to you from Storm Products. I think the biggest thing, a lot of times, people always want to know what's the difference between a symmetric and an asymmetric bowling ball. And it's always like, oh my gosh, is that too much to try to grasp? And it's actually a really easy concept. Most of all the balls that were made throughout history were symmetric bowling balls. Asymmetrics really didn't come around until the 90s and really in prominence the 2000s and today. And you'll see a lot more of those as future releases with the changes to USBC rules. But the biggest thing with a symmetric ball is, the thing to think about is, on this phase 3 we notice we have a pin, and that's where we use as our locator. As a pro shop operator, we're going to put our pin in a spot to try to give us the right type of motion. And we have a center of gravity mark, but in a symmetric ball, this pin on this ball is marked by the top of the weight block. So this top of the weight block marks that what we call an x-axis. And so we shift it a little bit off center inside that bowling ball to create a center of gravity so that we have a reference point for the drilling. Now, if I turn that center of gravity out and move it away, a little bit farther away, so if I put my fingers in a position where, let's say, the pin's above the fingers, and that CG is a little farther right, I think Lucas has a segment where we talk about where the balance holes go. In days past and up until August 1st, 2020, we can have that balance hole. But the CG dictates where that balance hole is going to go. But if I swing that center of gravity, which is going to fall anywhere around that x-axis, if I swing that left to right, there's really not any difference in that shape. So that's a symmetric. So truly, if I turn that any direction, if I turn that CG any direction, it's the same. I'm taking the same amount of mass. I'm not doing anything different to the weight block. So that's a symmetric. Now let's move over a little bit. We'll talk about astrophysics in a symmetric core. So in an asymmetric core, we're going to have a very much what we call a preferred spin axis. So let's not get too technical. So the pin in this one, if I spin it up here, if we look pin, there's that CG again, but all of a sudden we have another mark on the ball, mass bias. The way to think about that is, it's kind of like an axle on a wheel. So the pin is still referenced from the x-axis, but now the mass bias is marked over where we see that oval bolt on the side of this core. So now this is how the orientation of that weight block sits inside that bowling ball. So now if I swing this mass bias out to the right or closer to my axis or my vertical axis line, and I swing it out this way, it creates a different look in the lane. So now as this ball is tumbling down the lane, that axle or that wheel is actually trying to line itself up on axis to try to rotate down the lane. So now we have what we call a very defined preferred spin axis. And so I can take that mass bias, put the pin in the same spot, and I can swing that, say, below my thumb or just to the left of my thumb for a right-handed player. And the farther that I swing that mass away, the longer it takes it to orient itself traveling down the lane. So if I kick it way right, it lines itself up very quickly. So like if we were driving our car and we turn our wheels to the left, our wheels are going, and so our axle, everything is lined up in the direction of travel. Same thing happens when this gets lined up and it's rotating in the same direction as my ball track and my ball path, then it's kind of lined up. And we can make that moment happen very fast with asymmetrical balls. So we say those can kind of get what we call real defined change of direction, or we can make them very slow by putting that mass bias closer to the track. So it takes longer for that axle to line up in the direction of travel. So a symmetric, no matter which way I swing that CG, the mass is the same no matter how much I take out. It's where I tilt it, away from my axis point to create the differences in ball motion. But swinging the CG left to right really doesn't give me a whole lot of difference in reaction, other than up until August 1st, 2020, we can put a balance hole. In an asymmetric ball where I swing that CG and mass bias, also with how far I put the pin away from my axis, dictates how much ball motion I can create and where I can create it in the lane. So knowing that these asymmetric balls have a very defined spin axis, so when that ball rotates down the lane, as it's tumbling, it's also trying to right itself along its axis so that it's traveling with the direction of the track and the rotation. So we create a very strong preferred spin axis, a very defined shot shape, and as we move forward into the future of ball design, and with the changes to the USBC, you'll see a lot more asymmetrics, because if I can't put a balance hole in it, I really still want to define my ball roll. So thanks again for tuning in, and good luck out there.